Hello, welcome back to Lecture 6. And the next service I want to talk about is a truly revolutionary service called Lambda. The, the exciting thing about this service is that it represents a paradigm shift in the way that we build and architect and deploy our applications in the cloud. The Lambda service is an example of a platform as a service where we can write code and we can upload that code to AWS and run that code on AWS compute resources without having any understanding of the underlying operating system or underlying compute infrastructure that's required to support our application code. Lambda runs application code in response to events. So it's an event-based compute service. We call this sort of PaaS infrastructure a serverless architecture. Sometimes it's also referred to as no-ops, because as application developers, we don't have any understanding of the compute, storage, networking, the security requirements for our application code. We just write our code, upload it into Lambda, and let AWS run our code for us. Now, this is different than the previous service I showed you, Elastic Beanstalk. Elastic Beanstalk is automating the the launching of AWS resources and infrastructure components, things like EC2 and RDS and VPCs and so on. With Lambda, you don't see any of those infrastructure components. You don't see an EC2 instance in your dashboard. You literally write code, upload that code, and AWS will run it for you. And the code that you're writing is partitioned into functions. So you're not really creating like entire applications. You are building your application from multiple small modular functions, and each function is packaged into something called a Lambda function. Those Lambda functions are executed based on events which trigger the execution of the function. Now, this service is radically different than other services in AWS in terms of its billing model. You are billed based upon every 100 milliseconds that your code is executing and the number of times that your code is triggered, that your Lambda functions are triggered. When you're building an application, and there are companies now that are building entire platforms, their entire web application in Lambda, and they're building a series of Lambda functions and stitching them all together, and they're connecting Lambda with other AWS resources. So you could use Lambda to build your next generation application. You could also use Lambda to extend the existing functionality of AWS services. A very simple example is something like Route 53, where you could configure AWS so that every single time you add a new EC2 instance, the creation of the EC2 instance triggers a Lambda function which automatically updates a domain host record in Route 53. So you can use Lambda as this sort of integration glue that helps you automate different tasks within AWS. Here's how Lambda works. Basically, you write your application code, and Lambda supports a number of different application platforms. You write that code, and then you create a Lambda function using that code. You then configure your Lambda function to be triggered by other AWS services or HTTP endpoints or some sort of activity within AWS can trigger your Lambda function. When your Lambda function is triggered, then AWS will run your code, and you'll only be billed for the amount of time that your code runs. And your code will then perform some sort of action within AWS. Here's a very simple example. A customer could take a photograph and from their computer upload that photograph to an S3 bucket. The creation of that object in the S3 bucket could trigger a Lambda function, and the Lambda function could run code to automatically resize that image to generate the properly formatted images for multiple computing device types like tablets and laptops and mobile devices. So let me show you a quick kind of example of what this looks like. I go to the AWS console, and I'm going to click on services and click on the Lambda service under compute. And so you can see here, I've already got a couple functions that I've created. I'll show you what it looks like to create a new function. So we'll create a function, and I'm going to use, we could author the function from scratch, but I'm just going to use an existing blueprint. These are pre-configured templates that you can use. These are good for kind of learning purposes. And there's like, I think maybe hundreds of them available. I'll just pick this one, this S3 get object Python. Click that one. You give your function a name, a unique name, and then every function has to have a role assigned to it. When a function is running, that function may need to access different AWS resources. And in order for that function to access resources, it needs to have credentials. So you need to create a role and assign policies to that role which allow your function to access the appropriate resources within AWS. This role, this function already has this S3 read-only permissions role assigned to it. And then this particular function is going to access an S3 resource. And here we can specify which S3 bucket it's going to access. So I have a bunch of buckets. I could pick one of them. I can select the event type, which will trigger this function. In this case, I might say that I want any object that's created in this bucket to trigger the execution of this function. So anytime anybody creates a new object, uploads a new object into this S3 bucket, I want AWS to trigger this function. I'll keep scrolling down here. And now you can see the actual Lambda function code. We're essentially writing and this is in Python code, we're essentially writing a method in Python. And you can see here that it is pulling in the Boto3 library. This is a very, very popular library. This is essentially the AWS SDK. This gives you access to all of the different AWS API methods. And you can see in this Python code that we're creating an S3 client and this S3 object, and that will give us access to all sorts of different S3 API methods. We have a handler function here, this is the actual method that will be called by AWS when this function is triggered. And there's this convention that Lambda follows where it passes in an event object and a context object. And the event object will provide some information about the event. In this case, a user has created a new object in an S3 bucket, and in the event object that's passed into this method handler function, we can see some information about this object that was passed in, and all we're doing is pulling out some like metadata from this object and then returning it in this response. We are returning this response from this Lambda function. So a very, very simple function, and these functions can become as complex as you want them to be, and almost anything is possible. It's, as I mentioned earlier, companies are now creating their entire platform in Lambda functions and stitching these Lambda functions together. We call it serverless computing or serverless architecture. We're no longer thinking about our operating systems. We're no longer thinking in terms of like having to build all these different application services. We're taking all of these off-the-shelf services in AWS and stitching them together using Lambda functions, and that allows us to build very, very sophisticated applications. I can see now we don't do very much with Lambda yet in this course, and I could really see that changing in the future. I could easily do an entire lecture on Lambda. You could almost do an entire course on Lambda alone. And I think this represents a paradigm shift in the way that we develop applications, and in the future, it may be the case that many of our applications actually develop this way. Okay, let me go back to, so that was Lambda. Let me go back and continue the lecture here and talk just a little bit about security within AWS. Security is one of the primary concerns that organizations have when they move their resources to a cloud provider. And I think that the key thing to understand about security in the cloud, in particular when working with a provider like AWS, is that AWS implements a shared security model, which means that AWS is responsible for some of the security, and you, the customer, are responsible for some of the security. AWS is responsible for all of these different foundational services. It's responsible for maintaining the security of its data centers and different availability zones and regions and edge locations across the world. AWS is responsible for the underlying compute, storage, database, and networking infrastructure. But then above that, you, the customer, are responsible for everything else. You are responsible for ensuring that the operating system you deploy on an EC2 instance is properly configured and secured. You're responsible for ensuring that you're setting up the correct security group rules and the access control lists. You're responsible for deploying and securing your application properly. You're responsible for securing identity and access management and setting up difficult and challenging security credentials and enabling multi-factor authentication. setting up the proper roles and security policies on those roles. So this is a joint effort. You can't just simply deploy your application up to AWS and then forget about it and assume that AWS is taking care of all the security requirements and policies for you. That's not the way it works. AWS is responsible for their portion, which is those foundational core services, and you, the customer, are responsible for everything else. And that means that you need to have an understanding of security that permeates throughout your environment. Not just your operations people, but your application developers also need to be trained in good security practices. One thing I'll note that is that, and I think I noted this earlier on in this lecture series, AWS and Amazon are owned by the same company, but they use very similar infrastructure. They use the same technology, but they are separated from one another. So there's a logical and in many cases a physical separation between Amazon.com resources and AWS resources. And AWS, they implement a number of security prevention measures within their environments. For example, AWS prevents an attack called IP spoofing within AWS VPCs. So that prevents an EC2 instance from sending data with something like an IP address or MAC address that's not its own. Also, AWS mitigates port scans, network port scans. And a network port scan is oftentimes used by an attacker to perform sort of like an audit of your infrastructure. It allows them to see what network ports are open and to understand some of the potential attack vectors into your platform. And AWS actively tries to prevent and detect and mitigate network port scans. Now, there might be cases where you want to engage a third party to perform an audit of your platform on AWS. And as part of that audit, they'll want to perform a network port scan. Well, you can do that as long as it's approved in advance by AWS. And I'm guessing that they will temporarily suspend their network port scan alarms for your environment so that it can be scanned without triggering their sort of their mitigation tasks. One last thing I'll mention in this lecture is a feature within AWS called Resource Groups. And Resource Groups become handy when you start working with and managing lots and lots of different resources in the platform. Imagine you're an organization and you have created hundreds and hundreds, maybe thousands of AWS resources. Those resources could be split across multiple divisions in your organization, perhaps multiple teams. And, so the challenge becomes, well, how do you sort of categorize these resources? How do you associate resources with a particular team? And sort of how do you report on all the resources that you've created? You already know that you can assign user-definable metadata tags to nearly any AWS resource that you create, right? Every time you create an EC2 instance, you can create these tags. And those tags can be whatever you want them to be. A common way to use tags is to specify a team name or a project name that's associated with the resource. So once you've created all these different AWS resources, you can create something called a resource group to basically collect or group all of these resources together under one resource group name. For example, you could create a resource group associated with your team name, and you could group together all of the resources that have been tagged with your team. And the biggest benefit of this is that it's then much easier to view all the resources associated with your team across the entire platform. It's easier for kind of reporting and management purposes. If I jump back into the AWS dashboard here, you see this link at the very top. It says resource groups. If I say resource groups and create a group, then I'm presented with this configuration form here where I can create a new resource group. So I can select the type of resources that I want to group. So maybe they're EC2 instances, and I can specify a tag key that I want to use to group these resources by. And maybe I can also specify the values. So it's my project Fido. I want to group all these resources by that. Um, and then I can create a group. I assign a group name and a group description, and I can go ahead and create a group. And that will allow me to group together all of these different resources that match this grouping criteria that I've set. Very, very handy feature, especially when you have hundreds and thousands of different resources that you are managing in your environment.